And next, we see on the search for an element in BST how we can search through our data in the binary search tree. Okay, we need to loop, right? We need to loop recursive one by one until we reach the one that we trying to find. Okay, so we create a function here. Let's say boolean return true or false, and the parameter we need to know what is the tree based on the root, and we have the data that we want to search for. So the rule is that we try to search in every node. If that it does not found, okay, we return false finally. But if it return false, it means that our data is the same to root data. It means that we return true. Okay. But in case that our data that we want to search is greater than root, because we start from root, right? The beginning is from root. When we try to search, we check the root first. So based on the BST rules, we know that our bigger data, our greater number is installed on the right, the less stored on the left. Okay, so we check condition, right? If the data that we are trying to search here, whether it's greater than our current root here, okay? Because we search from root. So if our data is greater here, it means that we don't need to search from here, right? We just skip it, right? We just go to the right subtree here, because number is greater than 12. So it means that the number that we're trying to search maybe is on the left here. But in this case, for example, if we want to search for number 7, okay, so now number 7 is less than 12, right? It means that we should go to the left. Okay, should go to the left here, because number 7 we're trying to search. We start from the root here. 7 is less than 12, so it means that this condition is not true. This one is true. It means that we go to the left. Okay? We recursive to the left. So by calling to this function again, we pass the left nodes. Okay, the data is the same. We're trying to search this number in this tree. Okay, so repeating the same this process again and again until sometime it will reach the one that we want to search. But if it does not reach, it means that our recursion will reach the nil. It means that the data is not found. So we just return false. Okay, combining our code together in here, we can actually create a simple program to implement a tree data structure. So first here we create a node, because node is considering on this circle box here, right? Any circle box, it has the pointer connect to left child and right child, right? So you can say, okay, the data that you want to store, you have the node left pointer, which is the pointer to access to the left, so that you can connect, right? By default it's nil, okay, when we don't have the child left. So to insert the function, yes, this is what I have mentioned earlier in the slide, on how you can create a function to insert our data using this format. Okay, so we try to recursive, right, based on BST rule. If our data is less than root, so it means that we recursive less, so we root left here. So we call this function and we put it back to this left here. So until sometimes that it will reach the place that it can insert into. It means that that place is a nil pointer. So now we can new there. Okay, we create a new element inside that place. Okay. And finally, we just return this one, and how we can search just now, and the way we access to our data using the pre-order function. Yeah. If you try a different way, like in order and post order, you can just put the way you display it in somewhere, okay, in the middle or in the last code here between these three. Okay, this one, because we use pre-order, it means that we display first, then we recursive left and right. Okay, and to test our program in main, okay, you can create a main here. Let's say you create a root. So now, because we have a create function insert, right, so you can actually call to this one. Okay. Okay, so in here, after create root here, we can say root equal to insert something, because you have this function, it return, right? So we call to this function, and then we pass our root and then our data. So we keep adding the element into this tree, and next we display something on our program, right? And this is just to display a new line. ENDL here and line. So pre-order root here calls link to this function. We will obtain the information here, for example. So I think you can create your implementation in the code and also try to search a function in here. I think that's it for this slide. And in order to get the size of the tree, for example, we want to find, right, how many nodes inside the tree. You can create another function. Let's say get size here. It return a number, and the parameter is root, and you can actually recursive function, recursive left and right, and then you count it. So if root not equal to nil, you return 0. Otherwise, you return 1 plus recursive left and recursive right? Because we try to reach in every node of the tree in the left and right? And then each time we visit it, we counter, okay, 1 plus something. Okay, this is, it will keep incremented if we have a node in each of the subtree. Okay. I think you can implement it in your program and test it. And you can also display using in order and post order traversal by add more function here. So now we have pre-order, right? Just add 2 more function, post order, in order, and the rule here you just put in the place that it right to its method, whether you put in the middle or in the last. Okay. So I think that's it for this video. We're going to implement it together in a later time, and maybe in the next video we're going to see it again, okay, just to recall it what we have seen and implement in our code. And just to remind you that our data in here is not only a letter or number. You can actually store the data like student data or name or some other information that you need. And based on the rule, whether you insert left or right, you can pick up something that is based on. For example, you store the piece of data. Here is the students. So student, they may have ID, right? You can pick up ID and use it as a unique, identifier that used to comparison with the left or right. Our data should be inserted into. You can put it, in case it is a string, okay, you can use the method like some ASCII code together and find the number. If the number is greater, you go insert into the right, so on and so forth. It's just way we can design it by ourselves based on our development. Actually, there's no rule on that. So that's it. Thank you for your attention.